Hello learners, and welcome to today's lesson of parallel lines and perpendicular lines. Let's start off our lesson with a did you know. So did you know that most rooms have parallel walls and walls that are perpendicular? Walls of a room are perpendicular to the floor. Shelves of a bookshelf, kitchen cupboard, wardrobe, etc. are parallel. This lesson will describe the meaning of parallel and perpendicular in mathematics. Let's look at what you will learn by the end of this lesson. So by the end of this lesson, you should be able to write clear descriptions of the relationship between angles formed by parallel lines, cut by a transversal line, and perpendicular lines. You should also be able to solve geometric problems using the relationships between parallel, intersecting, and perpendicular lines. Let's look at the concept map for today's lesson. Of course, the focus is parallel lines and perpendicular lines. So we are going to be looking at parallel lines, where we are going to look at corresponding angles, co-interior angles, and alternate angles. Then we are going to look at perpendicular lines, and then in the end we are going to be looking at some problem solving questions. So for this lesson, you should be able to calculate the angle formed if two straight lines or line segments intersect. Also, you should be able to identify parallel lines, perpendicular lines, and transversal lines. Let's look at some pre-knowledge practice. Calculate the size of angles P, Q, and R. Now, before we start, I need to emphasize that all our diagrams have straight lines, unless otherwise stated. So as we can see there, we have been given unknown angles of a P, of Q, and of R. So we need to calculate the values of those three angles. And as a given angle, we have been given the value of 35 for that angle over there. So let's see how we can calculate the values of P, Q, and R. So firstly, let's look at P. And when we're looking at P, we can see that P is sharing a vertex with the angle of 35. And both of them are lying on this line, which is a straight line, PQ. So, as they are lying on PQ and they're on a straight line, what do we know about them? We know that angle P, when added to angle 35, will give us 180 degrees. And the reasons for this is that angles on a straight line, they are supplementary, or they add up to 180 degrees. So remember, when we are writing, we have to state a reason and an answer. So we are saying that P plus 35 is 180 degrees. Why? Because angles on a straight line are supplementary. Now, using the additive inverse of 35, we are going to say 180 degrees minus 35 degrees, and that is going to give us a value for P as 145 degrees. Then we are going to calculate the value of Q. So now we know that for P we have 145 degrees. So when we're looking at Q is also sharing a common vertex with the 35 degrees that's given there, and it is also on the opposite side of that common vertex. Now remember, angle Q and angle 35 degrees, they were formed by two lines intersecting, and because of that, not only are they vertically opposite, but they are also equal, because they are on opposite sides of that common vertex, and they are formed when two lines have intersected, as we can see there. So that means that our Q is equals to 35 degrees, and the reason for this is that they are vertically opposite angles that are equal. And that would be our reason for that calculation. So we know that that angle there is 35 degrees. What about angle R? Now, angle R is also formed by these two lines intersecting there. And when we're looking at that common vertex, we can see that angle R is opposite angle P. So since as well we found P as 145 degrees, then that means that also angle R is 145 degrees. And again, the reason why we are saying this is because those vertically opposite angles, they are equal. And there we have it. We have calculated angle P, angle Q, and angle R. Let's move on to our next pre-knowledge practice. Now here we are looking at those lines that we have been given. So it says there, with reasons, determine which set of lines are parallel. So remember what parallel means. It means that the lines will not meet. The lines are inclined in the same way. And of course, there is a symbol in mathematics that we use to show parallel lines. So which lines here are parallel? If you are thinking of this set of lines, then you are absolutely correct, because these two lines have those arrows there that indicate that the two lines are parallel. Now, which set of lines here are perpendicular? So we know that these two lines are parallel. Which lines are perpendicular? Remember, perpendicular just means that it forms a 90 degrees. And since as well we can see that block there that indicates to us that that is a 90 degrees, then we can say that it is that set of lines that is perpendicular. And what about this set of lines? Because there's no symbol for parallel, there's no symbol for perpendicular, that means that they are not parallel and they are also not perpendicular. The next set of questions here says, which lines are the transversal lines? Now, when we think of a transversal, we know that it is a line that cuts two lines here. So which lines here are cutting two sets of lines? If you are thinking of CD, then you are correct, because CD is cutting line ST and it is cutting line LM. We can see also that PQ is also a transversal. Why is it a transversal? Because it is cutting two or more lines. That is a transversal. So it means that PQ is also a transversal. What about LM and ST? Do you think they are transversal lines? Remember, a transversal line is a line that cuts two or more lines. Now let's look at LM. As we can see, it is cutting two lines, which is DC and QP. So that means that LM is also a transversal. And what about ST? As we can see, ST is cutting DC, it's also cutting QP, and it is cutting HG. So it is also cutting two or more lines. In this case, it's cutting three lines, which means that ST is also a transversal. So let's look at the questions there in our box. Now, do you know which line is the vertical line? Well, if you are thinking that the vertical line is PQ, then you are absolutely correct, because PQ is a vertical line as it moves from the top to the bottom, or from the bottom to the top. What about a horizontal line? Do you know which line is the horizontal line? Well, if you are thinking that the horizontal line is LM, then yes, you are correct. And ST is also a horizontal line because it moves from the left to the right, or from the right to the left. So those are the horizontal lines. What about an inclined line? Now, an inclined line is a line that is not vertical and it is also not horizontal. So it moves in an inclined or at an angle. So which line do you think is inclined? If you are thinking of DC, then yes, you are correct. DC is inclined. Which other line is inclined? Yes, GH or HG is also inclined. So even though it is not a transversal, but yes, we can identify it there as an inclined line. Let's look at some keywords that we are going to be using during this lesson. So we have there corresponding angles. Now, corresponding angles are angles which occupy the same relative position at each intersection where a transversal line crosses two or more lines. Then we have interior alternate angles. Though the interior alternate angles are angles that occur on opposite sides of a transversal line between the lines that it cuts. Then we have exterior alternate angles. Exterior alternate angles are angles that occur on opposite sides of a transversal line outside the line that it cuts. Then we have co-interior angles. Co-interior angles are angles on the same side of the transversal line between the two lines that it cuts. And co-exterior angles, those are angles on the same side of a transversal on the outside of two lines that it cuts. And those are the words that we are going to be looking at during this lesson. Let's quickly go to an ad break and then we'll see you just now.